So now that we've got a basic understanding of how the ASA appliances work, we're going to take a look at configuring SSH access, as well as configuring some of the IP addresses that we need. First things first, I'm going to pop down to the bottom and grab a 5505 appliance. And I'm also going to grab a end device. It could be a laptop or a desktop, really doesn't matter. We just need something to connect these two together. So what I'm going to do is take a Ethernet cable and go from the laptop fast Ethernet 0 to the firewall on Ethernet 01. We're going to fast forward time until we see that connection come up, and then take a look at the ASA as well. So I'm going to take a look at the ASA, and I get into the enable mode. Remember, there's no password out of the box. We're going to take a quick look at the running config. Okay, so we can see our 8 Ethernet interfaces and our 2 VLANs where the routing actually happens. So VLAN 1 is inside, VLAN 2 is outside. We can see their security levels and IP addresses as well. So out of the box, VLAN 1 already had an IP address on it. We just need to make sure that the port that we plugged into is a member of that VLAN. Going further down, on the inside interface, or VLAN 1, we're also handing out DHCP addresses, so that laptop should get an address just fine. I'm going to do a show switch VLAN and take a look at who actually belongs to the inside VLAN. So according to this, it is ports 1, 2, 3, and 4 are inside. 5, 6, 7, and 0 are the outside ports. If we go back to our diagram, we're plugged into port 1, so we're on the inside VLAN. Let's make sure that this laptop gets an IP address. And perfect, everything looks good there. Next up, we'll be actually configuring SSH. It's a little bit weird in Packet Tracer. There's some of the features that seem to break it, but I'll kind of talk about that as we go through as if you were actually doing this on a physical ASA device. The first thing that we're going to want to do when we go into the ASA is go into config T and change our enable password. So I'm going to say something like enable password of Cisco, which I know is a terrible password, but for the sake of an example, this will work just fine. The next thing that we would normally do is create ourselves a user account. So I'm going to say username, Mike, password of, I'll use Cisco again for a password, and typically we'd have to set your permission levels. In Packet Tracer, we don't need to do this, but on the actual physical ASAs, you more than likely will. The way you would set your permission level is by setting the privilege, and you'd say something like 15 for a very, very high privileged user. For right now, though, we just need our username and password combo. Next thing that we'll do is we'll configure some of the SSH properties. So since we're on the topic of authentication, we'll set it up to use our local username and password that we just made. So what we'll do for that is we'll go AAA authentication SSH console and then local. What that does is tells the firewall to look at your local database of usernames and passwords when you're trying to authenticate a user. You can also do things like SSH through that, or telnet rather. So if I did AAA authentication, question mark, we obviously won't use telnet, but in the real firewalls, we can do quite a bit more than just telnet and SSH. So we've changed our enable password. We've created a user account. We've told SSH to look for those user accounts locally. We need to just configure a few more properties of SSH. I want to set up the timeout. The timeout is how long can a computer stay actively connected while there's idle time, so nothing happening before we boot them off. I'm going to choose 5 minutes. And lastly, we need to allow what subnets are going to be incoming for SSH. So if we do an SSH, we can see that we have the format here of the network ID, the net mask for that ID, and which interface are we expecting SSH connections on? For right now, we're going to do those on the inside interface. Last thing we're going to do here real quick is test it out. If I go back to my laptop and I SSH, it's going to ask for the password. We should be able to get to enable mode. And perfect, there we have it. Now, one thing I'd highly recommend doing in a production environment is generating a little bit stronger or non-default keys. I've had problems with Packet Tracer doing this in the past, so we'll see how we end up. The way you generate new SSH keys is you do a crypto key generate. We can only do RSA keys here in Packet Tracer. And how big of a key are we going to make? We could say something like 2048 bits. This will wipe out the default SSH keys that we had on this and replace them with our newly generated ones. When I do this though, I've noticed on Packet Tracer at least, that our SSH usually doesn't want to connect again. So I try to SSH again. Yeah, this is what I see with Packet Tracer. The connection actually opens, but it never asks for our authentication. Not a big deal, just something to be aware of in the Packet Tracer world. This usually works fine on the actual physical equipment. So that's all I had in this video, was just quick VLAN assignments, SSH configuration, and remote access.